Greetings, Dr. Dan with Optimal Optics, here to answer some word problems about Unit 4, reflection at a spherical surface. If you have not viewed the video of Unit 4, now would be a great time to do so. The radius of a concave mirror is 30 centimeters. Paraxial rays proceed from a point 60 centimeters in front of it. Find where they are focused after reflection. So we'll draw our optical axis. We'll draw our mirror. Being a concave mirror, the center and the focal point will be on the left side. We'll place our object at point M. It's twice the radius. And we'll give the object some size so we can construct our rays. The parallel ray is reflected through the focal point. We'll send a ray through the center along the normal, and we see our image we predict should be real and inverted and somewhere around there. Now let's plug into our mirror formula and see if we get an answer that more or less matches our diagram. So our object distance is AM, A being the vertex of the mirror. It's a negative direction, right to left. Negative 60. The radius is also negative. AC, right to left, negative 30. We'll plug into our formula, and we'll isolate our variable on the left side of the equation. We'll get our common denominator, and we find that U prime equals negative 20 centimeters. That means it's on the left side or in front of the mirror. It is real. Question 2, the radius of a concave mirror is 60 centimeters. A luminous point is placed in front of the mirror at a distance of 120 centimeters. Find the position of the image point. Optical axis and mirror, still concave. We'll still place our center and focal point on the left side. The mirror's vertex is A. We'll place our object at point M, about twice the radius. We'll construct our rays, parallel through the focal point, ray through the center, and we predict our image will form where those two lines intersect. Plug in again into our mirror formula. Now U is equal to negative 120, AC right to left. Our radius is negative 60, pardon me, U is AM, negative 120. The radius is AC, negative 60. We'll plug into our formula, and we find that U prime equals negative 40 centimeters. That means it's to the left or in front of the concave mirror. Real image. Question 3, an object is 10 centimeters in front of a convex mirror of radius 60 centimeters. Find the position of the image. Create our optical axis and our mirror. Now this time, being a convex mirror, the center and the focal point will be on the right side. A is the mirror vertex. The focal point is halfway between A and C. And we'll place our object 10 centimeters in front of the mirror, pretty close to it. We'll construct our parallel ray that reflects through the focal point. We'll construct our ray along the normal. Those two rays intersect just behind the mirror, forming a virtual erect image. Now we'll plug into the formula. U is equal to negative 10, AM right to left. R is negative 60, pardon me, R is positive 60 going from left to right, AC. And we find when we isolate U prime on the left side, get a common denominator, and then find the reciprocal of that fraction. We get u prime equals 15 over 2, which is the same thing as 7.5 or 7.5 centimeters. So it makes sense. Positive number, am prime, will be behind the mirror. Number 4, an object is placed at a distance of 60 centimeters in front of a spherical mirror. The image is found to be on the same side at a distance of 20 centimeters. What's the focal length, and is it concave or convex? So since both the object and image are on the left side of the mirror, they both have negative values. AM is negative 60, AM prime is negative 20. We want the focal length, so now we set 1 over u plus 1 over u prime equal to negative 1 over f. We plug in what we know. We get our common denominator of 60. We find negative 1 over 15 equals negative 1 over f. So f is 15 centimeters, which means it is a concave mirror. F is measured from the focal point to the vertex. We'll draw it here. Make sure it makes sense. So it's a concave mirror. C and F are on the left side. Place our object at point, right at that point, and send our parallel ray reflecting through F, or ray along the normal through C, and we see our image is inverted and real, about the distance we expected. How far from a concave mirror, focal length 18 inches, must an object be placed so the image is magnified 3 times? Now, the image may be erect or it may be inverted. The magnification formula is m equals f over x. So we'll set the magnification equal to a positive 3 first for an erect image. And we find x equals 6 inches. That's the distance from the focal point to the object, meaning u is negative 12 inches. If we have an inverted image, the magnification is negative 3. And we find x equals negative 6 inches in that case, which means u is negative 24 inches for our inverted image. Now, to explain these in a little more clarity, let's draw our diagram, and that'll help explain where these numbers came from. So the focal length is 18. It is a concave mirror. FA from focal point to mirror is a positive direction. We'll place our first object, creating the erect image, at M1, and we'll place our second object, creating our inverted image, at M2. Those are object positions. They have nothing to do with magnification. Okay, we'll send our parallel ray going through the focal point, and now we'll see where our image is formed from M1 by sending a ray through C, and we see, in fact, it is erect and much bigger than the original object. So that looks good. And now we'll send a ray, that's M1 prime, we'll send a ray from the second object through C, and now we find that the image is, in fact, inverted. And again, much bigger than the original object, so that's looking good too. Okay, remember that x is measured from the focal point to the object, while u is measured from the mirror to the object, and u prime is measured from the mirror to the image. So the focal length is 18. We found that x for the erect image was 6 from the focal point to the object. Therefore, that means that the distance from the mirror to the object, M1, must be 18 minus 6, which is 12. And since it goes from right to left, it is negative 12. That's where u equals negative 12 came from. Now, for the inverted image, we have x is negative 6 from F to M, going from right to left. So we add that to the 18, or negative 18 inches, from the mirror to the focal point, and we get that U equals negative 24 inches, producing the inverted image. That's where that number came from. Question 6, a candle flame 1 inch high is 18 inches in front of a concave mirror of focal length 15 inches. Find the position and size of the image. So here's our optical axis. Here's our mirror. It is a concave mirror. F and C are on the left. The candle flame is a little bit past the focal point. We'll put it there. And we'll construct our parallel ray, which reflects through F. And we'll construct our ray through the normal. So you can't see it, but you can imagine that the image is inverted and real and quite a bit bigger than the object over there. And the object is 1 inch high. Okay, let's plug into our formula. U is equal to negative 18. AM is going from right to left. The focal length is 15. So we're going to use our mirror formula, setting it equal to negative 1 over F, since the focal length is what we are given. We'll plug in. We'll isolate our U prime variable. We'll get a common denominator of 90. And we'll find that U prime is negative 1 over 90. So U prime equals negative 90, which makes sense based on the diagram. The image is 90 inches to the left or in front of the mirror. Now, how big is it? Y prime over Y equals negative U prime over U. Y prime is our unknown. Y is 1. We plug in our values for U prime and U. And we find that Y prime equals negative 5. That means it is inverted and 5 inches tall. And of course, it's also real. Question 7, an object 3 inches high is placed 10 inches in front of a convex mirror of 30-inch focal length. Find the position and size of the image. We'll draw our optical axis, our mirror being convex. F and C are on the right side. We'll place our object pretty close to the mirror, send our parallel ray reflecting through F, our ray along the normal, and they intersect just behind the mirror, forming a virtual erect image, M prime. We're given the size of the object is 3 inches, so Y equals 3. The object distance, AM, goes from right to left. It's negative 10. The focal length is negative 30, FA, and we're finding U prime. Plug into our mirror formula. Plug in what we know, and we're looking for U prime, which we will isolate on the left side. And we'll get a common denominator of 30. And we find U prime equals 7.5 inches. So it's a virtual image. Now they want the size, so Y prime over Y equals negative U prime over U. We'll plug in our values. 7.5 is the same thing as 15 halves. U is negative 10. And we find that Y prime over Y equals 3 over 4. y is 3. So we find that y prime will equal 2¼ inches, which means it's erect because it's a positive number. Question 8, a gas flame is 8 feet from a wall. You want to create a real image of it, which is magnified 3 times. Determine the position, the focal length, and the type of mirror which would give that required image. So we'll construct our wall on the left, our mirror on the right. If you recall Unit 4, a real object creates a real image if the mirror is concave. The candle is 8 feet from the wall. We'll call that position M. That means U, the object distance from the mirror, is labeled appropriately. And U prime is the image distance. The image is formed on the wall. So it's the distance from the mirror to the wall is U prime. Now, M now is a magnification, and that equals -3. Remember, a concave mirror produces an inverted image if you're outside of the focal point for the object. So the formula is -3 equals -U prime over U. We can cross multiply, and we get -3U equals -U prime. Now looking at the way the letters U and U prime and 8 are arranged, you can see that -8 plus U equals U prime. U and U prime are measured from right to left. Now we can add these two equations, and we get -8 minus 2U is 0, and solve for U. And we find U equals -4. AM from right to left. A is the mirror vertex. Now you can predict that U prime is going to be -12 based on the diagram. We'll plug in and make sure we get that, confirm our answer, and in fact U prime is equal to -12. It works. So now they ask for the focal length of the mirror. So we have to plug in our values of U and U prime to get F. So we have -3/12 minus 1/12 equals -4/12, which equals -1/3. That equals -1/F. So F equals 3 feet. That's the focal length. Okay, question 9. This is the most difficult question. I saved it for last, so it requires an entire page. A concave and a convex mirror, each of radius 20 centimeters, are placed opposite each other and 40 centimeters apart on the same axis. An object 3 centimeters high is placed between them. Find the position and size of the image formed by reflection, first at the convex and then at the concave mirror. If you recall Unit 3, when we placed an object between two plane mirrors, the image formed by the first mirror became the object for the second mirror. We'll use that same principle to answer this problem. The image formed by the convex mirror will become the object for the concave mirror. We'll draw our optical axis, our concave mirror on the left, our convex mirror on the right, our object midway between them. We'll call that location M1. The vertex of the first convex mirror is A1. It's convex, therefore C1 is on the right. A2 is our concave mirror. The second reflection will occur there. And C2 is to the right of A2. Remember, when the reflection occurs off of A1, it will reflect off the concave side of A2, facing A1. Now we're given that our object distance to the first mirror is -20, A1M1. Its radius is R1. The radius of our second mirror is R2, both in a positive direction, left to right. Now we'll do our object and image calculation for our first mirror, the convex mirror on the right. We plug in. We put our variable U1 prime by itself on the left side. We find that U1 prime, the image at the first convex mirror, is 23rd centimeter. So somewhere about there. M1 prime. Now that becomes the object for mirror 2. We'll call it also M2. And the object distance from mirror A2 is 40 plus 23rds, which equals 140 thirds. From A2 to M2, our left to right positive direction. Now we'll plug into our mirror formula again. Now this is our second reflection off of the concave mirror. Plug in what we know. Isolate our variable on the left side. 2/20th is the same thing as 14 1/40ths. So 140 is our common denominator, and we have our image distance, U2 prime, is 12 8/11 centimeters to the right of the concave mirror. Somewhere around there. Now, the magnification at the first mirror is M1. Don't confuse that with the location of the first object. This is magnification we're talking about now. It's minus U1 prime over U1. We plug in, and we get our magnification at the first mirror equals 1/3. Magnification at the second mirror is negative U2 prime, with apologies to Bono, over U2. We'll get our common denominator of 33. And we find this magnification at the second mirror, that's M2. That's not the location of the second object. Don't confuse those two M2s. We get negative 21 over 77. Total magnification is the product of those two individual magnifications. So we can simplify the math a little by dividing 3 into 3 and 3 into negative 21. So we get 1 over 1 for our first fraction. We get negative 7 over 77 for our second fraction. So that reduces to negative 1 over 11. Our total magnification is negative 1/11. That means it is an inverted, smaller image. Now to find the actual size, we do y prime over the object size 3 equals negative 1 over 11, and we get our image size of negative 3/11 centimeters. Inverted and pretty small. Now let's do some ray tracing to see if in fact these numbers make sense. We will have our parallel ray for our first object going through F1, our ray through the normal, and we see that M1 prime, which is M2, is formed just where we thought it would. Now we'll do our ray tracing at the second mirror. Parallel line going through F2, normal, and it is just where we thought it would be.